Bismillahirrahmanirrahim. We are here to attend the final PhD seminar of Mr. Saifullah Jamali under the kind supervision of Dr. Nek Mohammed and co-supervision of Dr. Riaz Hussain Mari and myself. Before proceeding, I would like to call Dr. Fayaz for recitation of Holy Quran.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم إنا أعطيناك الكوثر وصل لربك وانحر إن شانئك هو الأبتر صدق الله العظيم.
Jazakallah. Mr. Saifullah, he has been registered in PhD in October 2020 and he has completed his PhD work under the kind supervision of Dr. Nek Mohammed. His approval topic, that is elemental characterizations of cosmetic using different spectroscopic techniques. The chair of this seminar, Professor Dr. Wazir Ali Balach, and the expert of this seminar, Dr. Syed Shabar Raza. So with the permission of chair, I would like to call a student, Mr. Saifullah, to present his final PhD seminar.
Respectable expert, doctors, teachers, and dear students, I, Saifullah Jamali, today I present my final PhD seminar under the supervision of Dr. Nek Mohammed Sheikh. My research topic is elemental characterization of cosmetics using different spectroscopic techniques. I am working with under the supervision of Dr. Nek Mohammed Sheikh and co-supervision of Dr. Riaz Hussain Mari and Dr. Wasim Ahmad Bhutto. The outline of my seminar consists of aims and objectives, laser-induced breakdown spectroscopy LIBS, simple preparation, experimental setup, results and discussion, conclusion, list of publications, acknowledgement and references. Aims and objectives: to study the nanosecond laser interaction with a cosmetic sample, to find out the heavy elements in cosmetic samples, to study the hydrodynamic variations of emission lines with a delay time and distance, to study the plasma parameters such as the electron temperature, electron number density, inverse Brahms stalling, plasma frequency. To find out the concentration of heavy elements or trace elements present in a cosmetic samples. Novelty of work. Many investigators believe that throughout the globe, cosmetics are responsible for poisoning due to heavy elements. An extensive analysis of cosmetic users and non-users found that those who use cosmetic daily are often in skin disease such as skin rashes, multiple stretch marks, yellowish brown coloration, cancer, etc. due to presence of heavy elements in cosmetics. In present work, I have studied the elemental characterization of cosmetics using spectroscopic techniques. The cosmetic samples are taken from the local market of Hyderabad, Sindh, Pakistan. Introduction of LIBS. LIBS stands for laser-induced breakdown spectroscopy. It is an analytical technique through which one can determine the elemental composition of solid, liquid, as well as gaseous sample. Overview of LIBS process. LIBS process basically consists of three separate regions. One is known as plasma generation, second is known as light collection, and third one is known as spectral analysis. During plasma generation, a highly powerful laser light interact with the target material after passing from a lens, a convex lens. As a result, plasma plume is generated on the surface of a target material. So due to thermalization of plasma, this plasma emits radiations, and these radiations are known as the characteristic radiations. And these radiations are collected by a spectrometer, and finally spectrometer converts these radiations into spectral lines. LIBS process can be classified into three separate operations. One is known as laser material interaction, second is known as a laser plasma interaction, and third one is known as a plasma expansion. During laser material interaction, a highly powerful laser light interact with the target material. As a result, plasma is generated on the surface of a target material. So this plasma exists here in a nanosecond, while another laser pulse in a picosecond interact with this plasma. So this process is known as a laser plasma interaction. And finally, a high pressure is generated inside the plasma, and a plasma plume is formed on the surface of a target material. These are the names. Material evaluation. Material evaluation, basically it is a process of removal of material from a surface by heating it with a laser beam. So here our material is evaluated in the form of plasma. So this material evaluation depends on a two property. One is known as a laser property, second one is known as a sample property. Laser property may be pulse width, wavelength of a laser, and energy of laser, while sample property may be optical property or thermodynamic property. Creation of plasma on cosmetic sample using LIBS technique. So this light basically shows the plasma, and this is our sample. When a laser light comes from this side, and after passing from convex lens, this interact with a sample. As a result, a plasma plume is generated normal to the sample surface, and this is the light of that sample. And finally, we collect this light for analysis. Advantages of LIBS. The advantages of laser-induced breakdown spectroscopy are given below. It offers rapid analysis, required no or very little simple preparation. It required no contact with the sample, sensitive to all elements. The analysis spot is very small and scalable in a simple size. Applications of LIBS. LIBS have many applications in a different field, such as material analysis, industrial analysis, environmental monitoring, biomedical analysis, and military and safety applications, etc. respectively. Sample preparation. For sample preparation, we follow two steps. During step number 1, we have taken 10 gram of cosmetic mixed with 3 gram of wax powder using mixing machine. And finally, we take in a second step, basically electrohydraulic press, and finally our target samples are ready for analysis purpose. Samples. I have basically chosen 4 different cosmetic sample. One is known as a kohal, talcum powder, face blusher, and eyeshadow. Kohal belongs to Hashmi Surma, and the origin of this cosmetic is Pakistan. Talcum powder, enricher, it is coded as sample A, and it is from Malaysia. Kiriza, this is a sample B, and it belongs to England. Fair and Cute, simple C, it belongs to Pakistan. While for face blusher, Kilozina Beauty, it belongs to China, and for eyeshadow, Precious Loose, it again belongs to China. Experimental setup. The experimental setup basically consists of a NDOC laser, power supply unit, reflecting glass, focusing lens, target sample, optical fiber, LIBS spectrometer, and finally laptop. When a laser light comes out from a NDOC laser, this interacts with a reflecting glass. As a result, it changes its direction towards target material. After passing from focusing lens, it interacts with the target material. So as a result, plasma plume is generated on the surface of a target material, and due to thermalization of plasma, this plasma emits radiations, and these radiations are collected by a spectrometer through this optical fiber cable. And finally, this spectrometer converts these radiations into spectral lines. This is basically plasma plume, and this is the characteristic radiations. Results and discussion. In first set of experiment, we have chosen emission spectrum of kohal basically Hashmi Surma, produced by 532 nanometer laser. This is our target material, and the spot you can easily see here. These are basically laser spots, and we have taken multiple data, and finally we get an average data to reduce the fluctuation or noise. And this whole spectrum is its ranging is from 200 to 720 nanometer. And finally, we will analyze this spectrum. For analyze emission spectrum, or for clarification of emission spectrum, these peaks are emission lines. We divided this whole spectrum into small portions. In figure A, its ranging is from 216 to 249. Almost we have found lead emission lines except one carbon, which is observed at 247.85 nanometer. In figure B, its ranging is from 256 to 292. It is a bunch of a lead line. In figure C, its ranging is from 355 to 375. We have observed mostly lead lines. In a figure D, its ranging is from 392 to 408. We have observed calcium lines and lead lines. While in a figure E, its ranging is from 422 to 460. We have observed calcium, chromium, iron and barium. While figure F, its ranging is from 468 to 504. We have observed 3 zinc line and 1 lead line. In a figure G, it starts from 520 to 561. We have almost observed 3 lead lines and 1 iron line and 1 barium, 1 mercury line. While figure H, its ranging is from 580 to 670. We have observed sodium lines, hydrogen and lead line here. While in a second set of experiment, this is the emission spectrum of talcum powder plasma produced by 1064 nanometer laser. This is again our talcum powder sample. The spots are clearly shows that these are the laser spots or laser shots. We have again taken multiple data and finally we have get an average of all data. This is the average spectrum. So its ranging is from 300 to 780 and this whole spectrum is further divided into portions. In a figure A, its ranging is from 308 to 380. We have almost observed 4 emission lines and these emission lines belongs to calcium. While in a figure B, its ranging is from 383 to 432. We have observed 3 magnesium lines and remaining calcium lines are. Figure C, its ranging is from 440 to 489. We have observed almost all calcium lines. While figure D, its ranging is from 500 to 527. We have observed silicon, magnesium, calcium and remaining calcium lines. In a figure E, its ranging is from 530 to 591. We have observed chromium, calcium, aluminum and sodium lines. In a figure F, its ranging is from 608 to 618. We have observed 3 lines and these 3 lines belongs to calcium emission line. In a figure G, it starts from 632 to 648. We have observed silicon lines, 2 silicon lines, 1 chromium strontium and remaining calcium lines. In a figure H, it starts from 648 to 672. We have observed 3 calcium lines and 1 hydrogen line. Meanwhile, in a figure I, it's ranging from 700 to 710 to 735. We have observed R calcium lines. In a third set of experiment, the emission spectrum of face pollution and eyeshadow plasma produced by 532 nanometer laser, and in this picture, in this spectrum, this is a ranging from the ranging of this spectrum is from 200 to 720. The red spectrum shows for eyeshadow plasma, while for black spectrum it shows for face pollution plasma. Again, same pattern, this whole spectrum is divided into small portions, and in figure A, this is the ranging of this picture is from 330 to 340. This is the bunch of titanium, while in a figure B, its ranging is from 381 to 396. Almost we have found 3 magnesium lines, 1 iron, 2 calcium, 2 aluminum and 2 titanium lines. While in a figure C, we have observed titanium, lead, manganese, mercury and iron lines. In a figure D, we have observed calcium, chromium and iron lines. Meanwhile, in a figure E, it starts from 438 to 458. We have observed iron, titanium, calcium, mercury and barium lines. In a figure F, we have observed titanium. This is a basically bunch of titanium. In a figure G, it starts from 492 to 502. We have observed iron, barium and remaining titanium lines. In a figure H, it starts from 504 to 528. We have observed titanium, copper, mercury, lead, chromium, calcium lines. In a figure I, we have observed calcium and barium, sodium lines. In a figure J, we have observed calcium, barium and remaining calcium lines. In a figure K, we have observed barium and lithium and calcium. You can easily see that in a figure black spectrum there is a barium, while for red spectrum there is no any barium. That means we have observed the barium at this emission line but not observed in face pollution, but for eyeshadow we did not observe this emission lines here. So number of emission lines in all sample. For coal, we have observed maximum lines of lead, almost 30 lines of lead, and for talcum powder sample A, we have observed 19 emission lines of calcium. For sample B, talcum powder, we have observed 42 lines of calcium, and for sample C, we have observed 19 lines of calcium. While for face polisher, we have observed maximum lines of titanium, it is almost 44 lines, emission lines. While for eyeshadow, we have again observed 44 emission lines of titanium. Temporal variation of intensity. Temporal variation is basically variation of any intensity with respect to delay time. So this is the 3D graph of corresponding emission wavelength, and this graph shows that as the delay time increases, the intensity of each transition line continuously decreases. Delay time is basically the gap between plasma generation and light collection. So this delay time is measured with a microsecond. So let's suppose this is our target material, and this is a plasma plume generated on the surface of a target material. We put our spectrometer or optical cable at the near the core of plasma. So we did not change the spectrometer, but we only change the delay time. Delay time is basically time gap between plasma generation and light collection. As the delay time increases, the excited electrons or species continuously de-excited, due to which the intensity of a emission line continuously decreases. Temporal variation of intensity of lead neutral line 363.95 nanometer. So this A, B and C basically are the different images of spectrum or emission line. In a figure A, it represents the intensity of this emission line continuously decreases as the delay time increases. While in a figure B and figure C, this shows that not only intensity decreases, but the width of a emission line continuously decreases. You can easily see at 1 microsecond delay time, this is for 1 microsecond delay time. It has a maximum intensity and a maximum width. As the delay time increases, not only intensity decreases, but width of emission line continuously decreases. Meanwhile, same pattern is also observed in figure C. Axial variation of intensities of a transition line. So this is a basically 3D spectrum, a 3D graph of a corresponding wavelength, and this shows the intensity of each emission line continuously decreases as the delay time increases, as the distance increases. So again, let's suppose this is our target material and plasma plume is generated on the surface of a target material. We put our spectrometer or optical cable near to core of plasma. This is considered at the 0 millimeter distance. At a 0 millimeter distance, we have observed maximum intensity. So as we move our spectrometer away from target material, so intensity of emission line continuously decreases, and this intensity variation belongs to this equation. Here I is basically integrated intensity, h is the Planck's constant, c is the speed of light, lambda is the wavelength of, and g is the statistical weight, a is the transition probability, n is the total number of density of neutral element, and qt, this is a basically partition function with respect to temperature, and ej is the excited energy, and k is the Boltzmann constant, and t is the plasma temperature. Temporal and axial variation of Stark shift of emission line. In a figure A, this belongs to 266.31 nanometer emission line of lead. So you can easily see that this black spectrum or this black emission line belongs to at we have recorded this black at 1 microsecond, and this emission line recorded at 6 microsecond. There is a gap, there is a shift, and this shift is measured as a 0.02 millimeter, and this shift is known as a Stark shift, and Stark shift is basically shift occurring due to electric field. Meanwhile, in a figure B, we have observed 0.02 shift, while in a figure C, we have observed 0.013 for calcium ion 317.93. For D, calcium neutral calcium ion 373.69, we have observed 0.01 nanosecond Stark shift. Plasma parameters. Number one is the electron temperature. Electron temperature is the measure of average kinetic energy per particle inside a plasma. Electron temperature is an important parameter to describe the excitations and ionization process takes place inside the plasma. Intensity ratio method and Boltzmann distribution plot method can be used to determine the electron temperature. So this is a formula of intensity ratio method, while this formula belongs to Boltzmann plot method. Here TE represents electron temperature and E2 and E1 basically these are excited energies, and K belongs to Boltzmann constant, I is the integrated intensity and lambda is a wavelength, while A is a transition probability and G is a statistical weight. For intensity ratio method, the requirement is you must have a two emission line, either neutral, either ionic lines. Another condition is that the emission spectrum has a different excited state, but while their ground state remains must be same. While this equation, again here lambda is a wavelength, signal wavelength, I is the intensity, A is the transition probability, G is the statistical weight, and T, this belongs to upper level population, and Q is a partition function, E is the excited energy, K is the Boltzmann constant, and T is the temperature. So we have used two emission lines at 368.34 nanometer and 373.99 nanometer, and these emission lines belongs to neutral lead. While for Boltzmann we have used 6 emission lines of calcium to calculate electron temperature. The variation of electron temperature. This is the variation of electron temperature for Kohel. This variation is basically electron temperature varies along with the delay time. So we have found electron temperature for Kohel, it belongs to, its ranging is from 15,500 to 11,600 Kelvin. For talcum powder samples, electron temperature varies from, for sample A it varies from 11,000 to 3050 Kelvin. For sample B it varies from 12,400 to 4,300 Kelvin, and for sample C it varies from 13,700 to 4,910 Kelvin. While for face pollution and eyeshadow, electron temperature varies as 14,151 to 5,465 Kelvin for face pollution plasma, and while for eyeshadow plasma it varies from 13,302 to 4,157 Kelvin. There is a different different trend of a decreasing trend. This is due to we have found electron temperature using lead lines here, and for both talcum powder and face blusher and eyeshadow we have used calcium lines to calculate electron temperature. That's why they have different trending, and this electron temperature is decreasing along with the delay time or distance. This is due to thermalization and recombination of plasma. Next one is the electron temperature, electron number density. Electron number density is the number density of electron in a plasma. Electron number density is also an important parameter which describes the states of plasma, and Stark broadening line profile method is used to calculate or to determine the electron number density. This is a formula to calculate electron number density. Here delta lambda half is basically full width half maximum of any emission line. Omega is impact factor, and this can be calculated, this can be recorded from literature review. Ne is a electron number density, and this is the number. So this is again a formula for calculating electron temperature, and this formula is used when you use the emission line which belongs to H alpha line or hydrogen line. If you use hydrogen line, then you use this formula to calculate electron temperature. If you use other than hydrogen line, then you must use this formula to calculate electron number density. The variation of number density for Kohel, electron number density varies from 2.06 into 10 power 17 to 3.62 into 10 power 16 centimeter power minus 3. And this electron temperature, electron number density for Kohel sample, it varies along with the delay time. While for talcum powder sample A, electron number density varies from 9.29 to 4.49 into 10 power 16 centimeter power minus 3. For sample B, it varies from 7.71 to to 3.62 into 10 power 16 centimeter minus 3 power minus 3, and for sample C it varies from 6.54 to 2.19 into 10 power 16 centimeter power minus 3. For face pollution and eye shadow samples, electron number density varies from 6.08 into 10 power 16 to 1.02 into 10 power 16 centimeter power minus 3. This belongs to face pollution plasma, while for eye shadow electron number density varies from 1.03 into 10 power 17 to 1.98 into 10 power 16 centimeter power minus 3. And this variation is along with a distance, and the remaining variation is along with a delay time. Variation of intensity as the number density changes. This graph shows that as the number density changes, the intensity of each emission line continuously changes. For this black emission spectrum, electron number density is very much high. Due to this, the intensity of emission line is high. As the intensity continuously decreases, the value of number density continuously decreases. This is due to recombination or thermalization of a plasma. Plasma frequency. The oscillating frequency of plasma species is known as plasma frequency. Laser matter is also depends upon the reflectivity of target surface. The laser pulse absorbed or reflected from a target sample depends on a plasma frequency. So this is the equation to calculate plasma frequency, and this shows that a plasma frequency depends on a under root Ne, electron number density. As the electron number density decreases, the plasma frequency continuously decreases. Temporal variation of plasma frequency for sample A, number 1, Cohol sample. For Cohol sample, plasma frequency varies from 4.08 to 1.71 into 10 power 12 Hertz. For talcum powder samples, sample A, it varies from 5.51 to 3.83 into 10 power 10 Hertz. For sample B, it varies from 5.02 into 3.43 into 10 power 10 Hertz, while for sample C, it varies from 4.62 into 10 power 10 to 2.68 into 10 power 10 Hertz. While for face pollution and eye shadow samples, the plasma frequency varies as 4.46 to 2.01 into 10 power 10 Hertz for face pollution plasma, while for eye shadow plasma it varies from 5.8 to 2.55 into 10 power 10 Hertz. Inverse Bremsstrahlung coefficient. Inverse Bremsstrahlung coefficient is a process in which an electron absorbs a photon while colliding with another electron or ion. Electron temperature and electron number density are the most popular parameters that can be utilized and explore the existence of a plasma configuration. The inverse Bremsstrahlung coefficient is an important parameter of a production of plasma. This is the relationship to calculate inverse Bremsstrahlung. Alpha IB, it represents the inverse Bremsstrahlung, that is equal to 1.37 into 10 power minus 35 lambda power 3 Ne square and Te power minus 1/2. Here lambda is the wavelength of a laser, Ne is the electron number density, and T is the electron temperature. Temporal variation of inverse Bremsstrahlung absorption coefficient. For sample 1, Cohol sample, inverse Bremsstrahlung varies as 7.03 to 2.51 into 10 power minus 5 in centimeter power minus 1. So this inverse Bremsstrahlung varies along with a delay time. This is again due to thermalization and recombination process. Sample B, second, talcum powder. For sample A, it varies from 1.36 into 10 power minus 3 to 6.02 into 10 power minus 4 centimeter inverse. For sample B, it varies from 8.81 to 2.28 into 10 power minus 4 centimeter inverse. For sample C, it varies from 6.04 to 1.44 into 10 power minus 4 centimeter inverse. While for face pollution and eye shadow, inverse Bremsstrahlung varies as 6.41 into 10 power minus 5 to 4.3 into 10 power minus 6 centimeter inverse. This is due to this is for face pollution plasma, while for eye shadow plasma, inverse brainstalling varies as 1.9 into 10 power minus 4 to 1.27 into 10 power minus 5 centimeter inverse. Calibration free LIBS technique is the technique which is used to find out the concentration of elements present in any sample. Saar-Boltzmann equation concentration. So this equation is used for calculate atomic species, and this equation is used to calculate ionic species. The concentration of atomic species plus the concentration of ionic species is used in this equation. So this is the equation, the total atomic or ionic concentration. We must add the ionic concentration plus atomic concentration to calculate total concentration of any element present in any sample. Concentration of elements present in a Kohl sample. So we have found we have used two techniques here, calibration free LIBS and AAS, and in both techniques we have observed the lead has a maximum concentration, while in ETX we have again observed lead has a maximum concentration. The concentration of elements present in a talcum powder sample. So using calibration free LIBS and AAS basically atomic absorption spectroscopy, we have observed calcium as a maximum concentration in using both technique in a talcum powder sample, while for EDX we have observed calcium as a maximum weight percentage or concentration. So concentration of elements present in a phase polisher and eye shadow. So we have observed titanium has a maximum concentration using calibration free LIBS method in a phase polisher and eye shadow technique. Error budgets. There is also fluctuation in reproducibility of the data due to the following reasons: fluctuations in laser energy measurement, fluctuation in a lens to sample distance, roughness of a sample, or geometric position of a sample surface with respect to laser. Conclusion remarks. We have observed LIBS is a very useful technique for elemental analysis of material. The emission lines observed in a cosmetic sample. For Kohl, we have observed lead, calcium, iron, zinc, barium, sodium, hydrogen, carbon, and mercury. For talcum powder, we have observed these emission lines, while for a phase polisher, we have observed these emission lines. The intensity variation of emission lines decreases with a temporal as well as axial variation. The stark shift occurs in a transition line due to microelectric field present in a plasma. We have observed maximum concentration of lead in a Kohl, maximum concentration of calcium in a talcum powder, and maximum concentration of titanium in a phase polisher and eye shadow. The variation of plasma parameters. These are the basically plasma parameters variations for each sample. Acknowledgement. I am thankful to my respectable supervisors for their suggestions and cooperation throughout the work. And I am also thankful to the Dean Faculty of Natural Science who provide the opportunity to present my research work timely. This is the LIBS setup, laser induced breakdown spectroscopy experimental setup in Quaid University, Islamabad. This is our power supply, and this is the main source laser, and this is a target material holder, and here prism is used as a reflecting material, and this is basically a convex lens. And these are a list of publications. Recently our two papers are published in a Elsewhere Journal Optics, and this is one is a one is known a critical review paper, and Kohl paper is also published, and remaining one is a soil and lithium fluoride. References. Thank you for your valuable time.
Thank you very much, Saifullah. Now this is time for question from audience. Firstly, I would like to So from audience, any questions from audience?
सर जे में गलायो जी सर यस सर यस सर सर दोनों हैं नेशनल भी इंटरनेशनल भी यस सर जी सर सर जो मेरा मेन इशू है ना एनालिसिस का पूरा टेक्निक वो ये है कि एलिमेंटल एनालिसिस ठीक है उसमें देखने ये है कि जो मटेरियल हम यूज़ कर रहे हैं उसमें कौन कौन से एलिमेंट्स प्रेजेंट हैं उसमें हमें ये पता चलेगा कि हैवी एलिमेंट्स भी हैं और इसके अलावा कुछ ऐसे एलिमेंट्स हैं जो हमारे लिए फ़ायदेमंद हैं वो बस जी सर बिल्कुल फिजिक्स का प्रॉब्लम ये है सर टेक्निक हम यूज़ कर रहे हैं ठीक है उन मटेरियल में मटेरियल्स जो हम यूज़ कर रहे हैं पहले हम सैंपल बनाते हैं उसके बाद लेज़र हिट करते हैं और लेज़र हिट करने के बाद जो उनके अंदर एटम्स होते हैं या इलेक्ट्रॉन्स जो होते हैं एटम के अराउंड्स वो एक्साइटेड हो जाते हैं और उसके डी एक्साइटेशन के बाद जो इमिशन मेरी जो मेन थीम था ना सर वो यही था कि ट्रेस एलिमेंट्स फाइंड आउट करने हैं उस मटेरियल के अंदर यस सर ठीक है सर व्हाट यस सर जी जी वहीं पे है सर उसमें बेसिकली हम टोटली जो प्लॉट्स वेरिएशन कर रहे हैं ना डिले टाइम एक्सियल में या फिर टेम्पोरल में वो बेसिकली इलेक्ट्रॉन जो डी एक्साइटेड होते हैं ना एलिमेंट्स से के तो कुछ जैसे ही डिले टाइम इंक्रीज होता है हमें पता है कि इलेक्ट्रॉन जब एक्साइटेड होता है उसका जो लाइफ टाइम है वो 10⁻⁸ सेकंड है एज हम डिले इंक्रीज करेंगे तो वो इलेक्ट्रॉन डी एक्साइटेड होते रहेंगे सो डी जैसे ही इलेक्ट्रॉन डी एक्साइटेड होते हैं वो रेडिएशन से इमिट आउट करते हैं मैंने उनमें वेरिएशंस देखे अगर मैं मटेरियल्स चेंज कर रहा हूँ उनमें किस तरीके से वेरिएशन आ रहे हैं जैसे कि इलेक्ट्रॉन टेम्परेचर की हम बात करें तो मेरे एलिमेंट्स चेंज किए कोहल में जो इलेक्ट्रॉन टेम्परेचर फाइंड आउट किया वो लेड एलिमेंट से फाइंड आउट किया जैसे दूसरे जो हमारे पास सैम्पल्स हैं टेल्कम पाउडर और इसके अलावा फेस पॉलिशर और आई शेडो उसमें कैल्शियम यूज़ करके हमने इलेक्ट्रॉन टेम्परेचर की वेरिएशन किए अब हमें दोनों वेरिएशंस डिफरेंट मिल रहे हैं इसमें से हमें ये पता चल रहा है कि अगर हम एलिमेंट चेंज करें तो जो डिक्रीजिंग ट्रेंड है वो मुख्तलिफ होगा देखिए सर इलेक्ट्रॉन टेम्परेचर जो है ना वो अगर हम एलिमेंट चेंज कर रहे हैं ना जो इसके अंदर एक्साइटेड एलिमेंट्स होते हैं उनकी जो कैनेटिक एनर्जी है ना वो बराबर होता है 3/2 kT, ठीक है। अब ये इसको हम बराबर कर रहे हैं इलेक्ट्रॉन कैनेटिक एनर्जी से, और कैनेटिक एनर्जी की जब भी बात आता है तो वहाँ पे मास ऑफ एलिमेंट्स भी आता है, ठीक है, या मास ऑफ इलेक्ट्रॉन्स। हर एलिमेंट की जो एक्साइटेशन और डी एक्साइटेशन जो होती है ना वो मुख्तलिफ होती है, उस वजह से ये वेरिएशन आ रहा है इसमें। हम्म। हम्म। जी सर। हम्म। 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 यस सर। यस सर। यस सर। यस सर। सर गैप जो है ना उसमें हमने मटेरियल पे लेज़र हिट करके और जो एलिमेंट्स हमने फाइंड आउट किए ना वो हम्म। हम्म। यस सर। यस सर। सर। हम्म। हम्म। सर ईडीएक्स जो होता है ना, ईडीएक्स में इसका जो फुल फॉर्म है वो है एनर्जी डिस्पर्सिव एक्सरे। हम एक्सरे यूज़ करके जो इनर्शियल ट्रांजिशन करते हैं। यस सर, कंफर्म। मेन ऑब्जेक्टिव जो है वो है ट्रेस एलिमेंट्स फाइंड आउट करना, और दूसरा जो है वो ये है कि हम देखना चाहते हैं कि उसके अंदर हैवी एलिमेंट्स हैं या नहीं है, क्योंकि हमारे इन्वायरमेंट में या सोसाइटी में जो लोग होते हैं ना, मोस्टली जो मैंने बताए थे कॉस्मेटिक्स, ये यूजेबल होते हैं, हर आम बंदा यूज़ करता है यहाँ पे, और उनकी वजह से स्किन डिजीज़ हो जाते हैं जो मैंने ऑलरेडी डिफाइन किए हैं, बताएं आपको। तो वो किस वजह से आते हैं, तो उनके लिए हमें देखना ये था कि उनके अंदर जो एलिमेंट्स हैं वो कौन कौन से हैं, अगर हैवी एलिमेंट्स हैं तो वो कौन से हैं। जैसे कि लेड है, अगर आप हाशमी सुरमा का बॉक्स ले लें तो उसके बॉक्स में के पीछे लिखा हुआ है कि लेड 0%, लेकिन हमने डिफरेंट टेक्निक यूज़ किए हैं, कैलिब्रेशन फ्री लिब्स, ETX और AAS, इसमें हमें पता चला कि लेड उसके अंदर एग्जिस्टेंस कर रहा है। आई थिंक सो। लेब न लिप्स टेक्निक असां जेको कयो वो एयर में कयो। इंस्ट्रूमेंटल अगर प्रॉब्लम हूंदो सर, इंस्ट्रूमेंटल अगर प्रॉब्लम हूंदो न पोइ हिकिड़े में हूंदो EDX में ऐं AAS में ऐं कैलिब्रेशन फ्री लिप्स में असांखे सभिनि में जेको कंसंट्रेशन हाई जेको मिलियो न उहो पंहिंजो हुनजो मिलियो आहे लेड जो। I have read many research journals, international and national journals, which have worked on cosmetics, just like Kohal. Some paper I have already read from. This belongs to from Saudi Arabia, and different Indian surma and different journals research papers are already worked in these cosmetics. So I was just proved. सर अगर कॉल की बात रिलेटेड है तो हाशमी सुरमा जो उसका अपना वेबसाइट है उसके अंदर आप जाएंगे तो वहाँ पे लाइसेंसेस का पड़ा हुआ है हाशमी सुरमा का, लेकिन उसमें मेंशन्ड है कि कोहल जो है उसमें कुछ भी नहीं है, लेकिन ना लेड उसमें कुछ भी नहीं है PP। लेकिन हमने डिफरेंट टेक्निक से फाइंड किया कि जो कोहल है उसमें लेड जो है वो मैक्सिमम कंसंट्रेशन होता है। सिर्फ में ही नहीं, डिफरेंट जो जनरल है इंटरनेशनल उनमें भी अगर वो कोहल को एनालिसिस करते हैं उनके पास भी लेड मैक्सिमम कंसंट्रेशन मिलता है।
Actually these are local made companies, तो उनके अंदर ये चीज़ें जो है ना वो काफ़ी सारे यानी प्रॉब्लम।
उसका लाइसेंस मैं आपको दिखा दूंगा सर।
ओके, एनी अदर क्वेश्चंस?
रिसर्च टेक्निक में तहां जेको लेजर शाइन पे थे सम रिफ्लेक्टिंग ग्लास यूज करेगा शायद।
यस सर,
प्रिज्म यूज करेगा रिफ्लेक्शन लाए ना
पिक्चर में।
हां
हाँ न हिते गिलास आहे, गिलास तां मिरर यूज़ करे ताकि लेज़र तव्हांजो रिफ्लेक्ट थी वञे।
उनखे रिफ्लेक्ट करण जी ज़रूरत थी छो सामू कन्वेक्स लेंस लगाए सामू ही असां सैंपल रखे।
इन सां इशू इहो थींदो त अगर तव्हां मटीरियल जे साम्हूं लेज़र रखंदो हिट कंदो न त जेके रेडिएशंस इमिट आउट थींदा इहो प्रोबेबिलिटी आहे त उहे रेडिएशन उन लेज़र जे अंदरि हलिया वञनि, उनखे हिट कनि, डैमेज कनि, ऐं लेज़र ऑलरेडी इलाही एक्सपेंसिव आहे त इन खे बचण लाइ असां रिफ्लेक्ट कयूं पिया ताकि मैक्सिमम असांजो जेको आहे उनखे सेव करे सघूं। जी
Okay, any other questions from chair or from expert?
स्लाइड
32. डेटा पॉइंट डिफरेंट आहिनि कुझु असां एक्सपेरिमेंट न सर कुझु एक्सपेरिमेंट असां वरिता आहिनि हुतां कैदाम यूनिवर्सिटी मां ऐं कुझु एक्सपेरिमेंट जेके असां कया आहिनि उहो फैसलाबाद मां कया आहिनि ठीकु आहे उन्हनि जो एतिरो ई सेटअप थियल आहे त उन हिसाब सां डेटा पॉइंट्स तव्हांखे डिफरेंट ॾिसण में ईंदा आहिनि न कुझु एक्सपेरिमेंट असां जीअं हीअ आहे हीअ जेके ॿई एक्सपेरिमेंट आहिनि इहे ॿई असां इस्लामाबाद मां कया आहिनि ठीकु आहे ऐं हीअ असां फैसलाबाद में कयो आहे ऐं हीअ बि असां फैसलाबाद में जी हाई खां लो इन जे करे अचे पियो त डिले टाइम इंक्रीज़ थिए पियो न जीअं डिले टाइम इंक्रीज़ थींदो त एक्साइटेड इलेक्ट्रॉन्स जेके हूंदा आहिनि उहे कंटिन्यूसली डी एक्साइट थींदा रहंदा आहिनि ऐं टाइम इंक्रीज़ थियण सां जेका अपर लेवल में इलेक्ट्रॉन्स जेका आहिनि उनजो तइदाद घटि थी थो वञे जंहिं करे उनजी इंटेंसिटी डिक्रीज़ थिए पई ऐं उन सां ई असांजो नंबर जेको आहे पंहिंजो टेम्परेचर उहो डिक्रीज़ मिले पियो असांखे एवरेज काइनेटिक एनर्जी हुनजो डिक्रीज़ थी वेंदो आहे अच्छा सही ठीक है सर मिनिमम
Okay, any other questions from chair?
yes sir
And I have found, in your dissertation that, sometime you have mentioned the, names, I mean, in English, like lead, and there is no any, elemental name, or we can say chemical name, KPB or something, copper or other things. So sometime, you have put the names in English, and sometime you just put the signs of elements. So I think it's better you can, write the name in English as well as their scientific, sign of the element also, so that, it will be very easy to understand.
yes sir
And it should be, throughout your thesis. Sometime you have written in one type, another is another type. So it should be homogenized, throughout your dissertation. In you gave yoga, so you have to think about that. So you have got so many questions, but the questions from the expert are remaining. So I give floor to the expert.
Thank you very much.
Most of the questions were asked.
Yes, unfortunately or fortunately, most of the questions that I would like to ask have been already asked, especially Dr. Saab has asked, and very important questions. But still, I have to ask something just to see that whether you have good grasp on your. Can you go to the slide 1, for example? Just yeah. Yes. How do you define this hydrodynamic variation of emission lines? But how do you define this hydrodynamic variation?
hydrodynamic variations are those variations inside the plasma which occurs due to the providing thermal energy.
Okay, so I'm really concerned with the word hydrodynamic. Yeah. Okay.
Hydrodynamic, dynamic variations,
I know.
and these variations occur due to when laser light interact with this sample.
Okay.
And there's a variation may be in terms of delay time, and variation may be in terms of distance as we move away from normal to the target material. So we will study these variations.
Okay. Oh, okay.
We should be replaced with thermal variations.
Yes.
I think it would be much better.
Yes.
Are you can justify that? It's okay.
Yeah, I was also thinking like this.
Hydrodynamic means how the plasma is state is changing
Yes.
the space and time.
Yes. In terms of plasma physics,
Yes,
if you really say, yeah. All right. Can you move to the another slide? Maybe it was slide 6. Okay. I mean, what do you? Yeah, that's right. That's I mean, because you defined laser-induced breakdown spectroscopy. I mean, what do you really mean by the breakdown? I mean, what is really breaking down here?
The breakdown, basically the material is evaporated in the form of plasma. This is the
Okay.
basically breakdown. We will remove the part material using laser.
Okay.
And this is the basically breakdown.
All right. So it's something like ablation.
Yes.
Okay. Okay. Please move to the slide 11, where you, I think, discussing the application. So, for example,
This one?
yeah. So you said industrial analysis. I mean, can you please, elaborate it?
Which one?
I mean, this industrial analysis, and yeah.
यहाँ पे सर लेज़र को इंडस्ट्री में भी यूज़ करके उसकी एनालिसिस जो मटेरियल हम बनाते हैं ना इंडस्ट्री में जो साइंटिस्ट होते हैं तो उनकी जो है वो करेक्टरिस्टिक देखने के लिए ये लेज़र ही यूज़ करते हैं ताकि उनको पता चले कि जो मटेरियल हम यूज़ कर रहे हैं उसके अंदर बेसिकली एलिमेंट्स कौन से हैं.
Okay. So, I mean, can we also use some other techniques?
Industrial?
Yes.
Yes.
Yes. Like what?
Like AAS.
Mm-hmm.
The AAS is basically not for elemental. They basically find out concentration of elements.
Okay. And what about this military and safety applications?
This is basically यहाँ पे जो है वो बेसिकली यूज़ करते हैं कि जो एक्सप्लोसिव मटेरियल है उनको भी एनालाइज किया जाता है कि उसके अंदर जो एक्सप्लोसिव मटेरियल है उनके अंदर कौन कौन से एलिमेंट्स मौजूद हैं. तो कुछ हैवी एलिमेंट्स होते हैं और एक्सप्लोसिव मटेरियल में जितने ज़्यादा हैवी एलिमेंट्स होंगे उतना वो अच्छा कहलाएगा मटेरियल.
Okay. अच्छा, in what sense?
Their destruction in a short time interval.
Okay. Okay, so please move to the next slide, slide number 10.
Which slide?
Yes, this please. You said you have used 10 gram of material. Is there any particular reason for using this particular number?
Sir,
10 gram.
ये कि जो मटेरियल ये जो सिस्टम है उसमें इतना स्पेस नहीं है.
Okay.
ठीक है, शॉर्ट स्पेस की वजह से हमने जो मटेरियल की जो वैल्यू रखी है वो 10 ग्राम सैंपल का रखा है और 3 ग्राम जो है वो वैक्स का रखा है. वैक्स इसलिए यूज़ किया कि हमारा जो सैंपल है वो इन द फॉर्म ऑफ प्लेट आ जाए.
Okay. So ये जो इक्विपमेंट है ये वहाँ पर QAU में है?
नहीं, ये इक्विपमेंट यहाँ पे जियोलॉजी डिपार्टमेंट में है.
जियोलॉजी में. Okay. Alright. और जो आपने लेज़र इस्तेमाल किया वो आपने नियोडिनम जैग इस्तेमाल किया है.
जी.
इसकी भी कोई ख़ास रीज़न है कोई या यही अवेलेबल थी?
यही अवेलेबल है. ये बेसिकली सॉलिड स्टेट लेजर है और इसको ही हमने यूज़ किया.
Okay. Can you move to slide number 17 also? Okay, so what is this big, high intensity line around 400 nanometer?
This one?
Yeah, this
This
one.
is basically calcium line.
Calcium line.
422.
Okay. So all these elements did you find here are in their elementary form or they are like kind of oxide also?
No, elemental form.
Elemental form.
Yes.
Okay. And please move to slide number 21. So you said about hydrogen lines here, right?
Yes.
So
There's no any hydrogen line in next page.
oh, okay, right.
This one.
Yeah. So why did you have this hydrogen here?
हाइड्रोजन हमें इसलिए पता है सर, वहाँ पे जो मटेरियल हम यूज़ करते हैं ना उनमें हाथ वगैरह लग जाते हैं और एनवायरनमेंट का जो एयर है मॉइस्चर वगैरह उस वजह से हाइड्रोजन मिलता है.
Okay, so आप कोई वैक्यूम वगैरह इस्तेमाल नहीं करते हैं. All right. And can you please move to the slide 30? Right. So here you repeatedly have said that because of the delay time, the intensity goes down. But in this figure C,
This one?
yeah. So what I really can see is that as the delay time, oh, this is decreasing. Oh, okay. Oh, this is decreasing there. Okay. I thought that it is starting from 0 to.
No, this one.
Okay.
One to start to last.
Okay. Yeah. Now I got it. All right. Okay. Thank you. And on slide number 31, you have shown I think the next one. Okay, over here. So how did you calculate this total number density of the neutrals?
Using already I have told to all of you, we have used stock broadening method.
And how do you define this? First of all, what is simply an Stark effect, and what do you mean really by this Stark broadening?
Stark effect basically when plasma is generated, there is many species, excited species, and there may be there are electron present inside that, and there is a variation, the variation of shift which occurs due to microelectric field. This basically is known as a Stark shift.
And microelectric field generated due to
Excited electrons. Basically, electrons are electric charges. They have a property of electric field.
Right. So you said total number of density of the neutrals.
Total number density again calculate. We have calculated this equation using this equation.
Which one?
This one.
Okay. So you know this delta lambda half, and you know omega, and then you find any. And where did you get this delta lambda half? I mean from the experiment.
Okay. Let's consider this equation line. This one, red one, okay?
Okay, you get from
this
there.
is the full intensity,
And
and
from the half
this is the full width, and the half of full width is known as the full width of maximum.
All right, so please move to slide 38. And I think that this question may be overlapped with the question already asked. That I want to know the physical significance of these numbers which you are showing here. For example, you said that this is the delay time and all these things. Okay, for example, if the delay time is short, what will happen? And if the delay time is say large, I mean how the physics will change, and how the importance of your result will change.
सर डिले टाइम जब शॉर्ट होता है तो उसमें हमारे पास जो पार्टिकल्स हैं प्लाज्मा के अंदर जो स्पीशीज हैं वो एक्साइटेड होते हैं, उसके पास एवरेज काइनेटिक एनर्जी बहुत ज़्यादा होता है, और एवरेज काइनेटिक एनर्जी ज़्यादा होने की वजह से जो पार्टिकल्स हैं वो वेरी क्लोज हैं, उनकी इंटेंसिटी जो है वो भी ज़्यादा होता है, और उस वजह से शॉर्ट एंड डिले टाइम में इंटेंसिटी अपना जो है वो नंबर डेंसिटी वो मैक्सिमम दिखा रहा है. जैसे ही हम डिले टाइम इंक्रीज कर रहे हैं तो वो इलेक्ट्रॉन्स जो एक्साइटेड स्पीशीज हैं वो डी एक्साइट होते रहते हैं कंटिन्यूसली. जैसे ही डिले इंक्रीज होगा तो डी एक्साइट हो गए, अपने ग्राउंड स्टेट में आएंगे, तो वहाँ पे जो है वो नंबर डेंसिटी मिनिमाइज हो जाता है.
ये जो फॉर एग्जांपल जो आपकी सेंट्रल फिगर है टैल्कम पाउडर की, इसमें यू आर शोइंग 3 लाइंस, तो ये 3 लाइंस किस चीज़ को शो कर रही हैं? बिकॉज आई कांट रीड द लेजेंड.
ये हमारे पास बेसिकली 3 सिंबल्स हैं टैल्कम पाउडर, अपना जो है टैल्कम पाउडर के.
ओके.
ये जो फर्स्ट लाइन है वो रिप्रेजेंट कर रहा है सैंपल A को जो लिटरेचर था.
ओके.
और सेकंड लाइन जो है वो दूसरे सिंबल्स को रिप्रेजेंट कर रहा है, वो सिंपल बिलोंग्स कर रहे हैं टैल्कम पाउडर से.
राइट. सो फॉर एग्जांपल इफ द मतलब अगर आपकी डेंसिटी नंबर डेंसिटी एकदम शार्पली गिरती है और किसी की देर से गिरती है, तो उससे आपकी फिजिक्स जो आप वहीं किसी को रिपोर्ट करना चाहेंगे कि भाई ये रिजल्ट इंपॉर्टेंट है या ये रिजल्ट इंपॉर्टेंट नहीं है, उससे क्या फर्क पड़ेगा?
इसमें सर दोनों इंपॉर्टेंट है. ये वेरिएशन हमें जो है वो इसमें शार्प डिले है, डाउन आ रहा है, यहाँ पे स्लो. ये बेसिकली जो एलिमेंट्स जो होते हैं ना, जैसे कि मैंने पहले ही बताया था कि ये जो हमें कैलकुलेट किया है वो डिफरेंट एलिमेंट्स है और इसका डिफरेंट एलिमेंट से कैलकुलेट किया है. तो हर एलिमेंट के जो इलेक्ट्रॉन्स होते हैं वो मुख्तलिफ उनका बिहेवियर होता है, उस वजह से ये वेरिएशन डिफरेंट आता है.
Okay, and how will you define this plasma frequency which you have shown on slide 40?
जिसमें
Yeah, and what are
जैसे हमारे पास इलेक्ट्रॉन जो है या स्पेशीज जो है वो एक्साइटेड है प्लाज्मा के अंदर, तो वो कंटिन्यूसली उनका तो एक तो काइनेटिक एनर्जी, एवरेज काइनेटिक एनर्जी हाई है, और दूसरी जो बात है वो एवरेज काइनेटिक एनर्जी हाई होने की वजह से उनकी जो वाइब्रेशन है वो ज़्यादा है, और उस वाइब्रेशन की वजह से जो फ्रीक्वेंसी हमें मिलता है वो प्लाज्मा फ्रीक्वेंसी कंसिडर होता है.
And you have also been talking about this inverse Bremsstrahlung.
जी.
And how will you define to the audience what is the inverse Bremsstrahlung?
इनवर्स ब्रेनस्टॉर्मिंग में बेसिकली जो इलेक्ट्रॉन है वो लाइट एब्जॉर्ब करता है बाय कोलाइडिंग इट्स नाइबर इलेक्ट्रॉन और आयन.
Okay.
जैसे कि लाइट जो है वो हमारे पास इस प्रोसेस में लेजर फॉर्म में होता है, जैसे ही लेजर इलेक्ट्रॉन को हिट होता है और वो इलेक्ट्रॉन अपने नाइबर जो आयंस हैं या इलेक्ट्रॉन से उनको कोलाइड करे तो ये प्रोसेस इनवर्स ब्रेनस्टॉर्मिंग कहलाता है, और इसकी वजह से ही प्लाज्मा फॉर्मेशन होता है यहाँ पे.
तो यहाँ अपने जो रिजल्ट्स हैं, हैव यू कंसीडर्ड दिस डॉपलर ब्रॉडनिंग इफेक्ट on something like this?
Yeah.
I mean, in your results, have you considered, Doppler's, broadening?
Yes. Doppler broadening basically light की वजह से ही होता है.
I know. But have you considered here?
No.
Why?
मैंने जस्ट रिजल्ट्स बताए यहाँ पे.
Okay.
और वो जो रिजल्ट्स हैं वो स्टॉक शिफ्ट या दूसरे जो टेक्निक यूज करके हमने जो रिजल्ट मिले वो जस्ट डिफाइन किए हैं.
All right. And I have also suggestion, for example, on your thesis, page 22, you have shown, these temperatures 2.5. You have shown 1000 like big K. Please use small K.
Yes.
Because K you are already using for Kelvin. All right. Okay, you have already shined this thing. Okay, that's fine. One more thing on your page 47. You have said on table 4.7 relatively a concentration of trace elements and coal. First of all, look, coal is a proper noun, so please write coal with the capital K.
Yes, sir.
Yeah, because you have already almost everywhere is with the small K. So you are writing this coal, this lead concentration and iron concentration with so many numbers. This must be consistent with the least count of your instrument.
Yes.
So was your instrument so much sensitive?
No.
So
This
please,
question already comes towards us.
Yes,
We have
yes,
submitted our
yes.
paper to an international journal.
yeah, because otherwise these numbers makes no sense,
Yes.
right? So please incorporate it. Yeah. So these are some of my suggestions, and please.
Okay, thank you very much. Now for expert opinion remarks, I would like to call Dr. Shabar Raza for his remarks.
All right, Assalamu alaikum. First of all, thank you very much for this invitation. I have gone through thesis of Mr. Saifullah Jamali, and I have found it quite reasonable for the degree of PhD. And as I have also told you that there are certain things which you should incorporate in your thesis, and otherwise I think it should be a reasonable thesis to be awarded for the PhD degree. But the most important thing is that, as people have already told you, that we are doing physics here, so your thesis must contain physics. These graphs, these numbers have no sense, make no sense if you do not explain them. So that is the most important thing. Numbers have no meaning, because we are doing physics here, not mathematics. If we are doing just mathematics and we are doing what we call as the just number theory, those numbers are fine. But we are doing physics, so we have to take care of all the physical aspects of these numbers. So I wish you all the best for your future. All right.
Thank you very much. And now, for concluding remarks, I would like to call Honorable Dean Faculty of Natural Science, Professor Dr. Wazir Ali Baloch, sir.
Bismillah Rahman Rahim. Our expert, Dr. Shabbar Raza from Federal Urdu University, Karachi, Dr. Nek Mohammed Sheikh, Dr. Imran, Dr. Sumru Sahab, Dr. Riaz Mari, and Dr. Wasim, sorry, Bhutto Sahab. Here is our lady teacher, Madam Asma, probably. And dear students, Assalamu alaikum. We took a lot of time, with today's scholar, Mr. Saifullah Jamali. And I'm really happy to see that he is so confident, and he took so many questions today. And his preparation for the seminar was very, very nice, very nicely presented. And there are so many, graphs and slides and all these things. But there are, a few things which are suggested by different, teachers as well as the experts. These should be incorporated. Actually, the research, first question for any research is, for any project, why? Why you want to do this thing? And if, say, due to this, these are your aims and objectives, then at the end, you have to answer these aims and objectives. And you try hard in your all, dissertation or thesis, what methodology actually that's, you used, it should be, acceptable internationally, the methods you use. So there were so many questions from Dr. Ibu Poto also. So he asked, where is the physics actually? So you must know where was the physics, because it's very much resembling to the chemistry also. And the instruments you use, these can be used for biological processes, for chemistry, for physics, for other subjects as well. But where was your physics, So you must be clear about that. And I have gone through your thesis and I have given you some suggestions also, because this is a process of learning. You have to take all these things positively. Actually, we want to improve your dissertation, we want to improve your whatever you have worked. Maybe it's sometime our suggestions are not good, maybe you think, but even we have to give you suggestions. So this is the way it works. So you were asked several questions, so you have to incorporate all these things, And because, your work is supported by the publications, so it's good that you have already published some publications. And your work is worth of, it shows the worth of your work. Only, all these things, after all these things, and you were the observer, all of you have seen, you have witnessed the final presentation, PhD seminar. So I think I have no hesitation to approve the final PhD seminar. I approve your seminar, and I congratulate Mr. Jamali, as well as the supervisors, Dr. Negmo Sheikh and probably Dr. Bhutto and Dr. Mari, I think, yeah. So congratulations to all of the supervisors. And I would like to thank again for the expert who has come from all the way from Karachi this morning. Thank you, Dr. And hopefully you will be coming again and again in the university. So thank you. And thank you all for coming over here and listening to the seminar. Thank you very much.
Thank you very much for all.
What do you really mean by this hydrodynamic variation?
Hydrodynamic variation in terms of these plasma parameters.